Good morning to the third day of the Storage Developer Conference. Today we have an SMB track, and I'm going to do the start on SMB. I'm going to talk about reparse points. To me, they have been new for like the last 12 months or so. I learned a lot, and I will tell you a bit about what we are going to do with them and where we are at this point. My name is Volker Lendecke. I am long-time member of the Samba team. I work for SerNet in Göttingen in Germany. We have many customers asking us for development tasks, but we also have customers that are actually running Samba. And just this morning, like at 4 a.m. when I woke up, a colleague contacted me, hey, it would be great if we could have SMB Unix extensions so that our customer XYZ doesn't convert back to NFS for his Unix clients. And so all this will be described in the next slide. We are going to do SMB3 POSIX extensions. And what I want to do is make SMB a competitor to NFS. And if you listen to Steve's talk about this topic, he always says this is more than just POSIX. Much more than POSIX. He speaks about hundreds and hundreds and hundreds of syscalls, many hundreds of them being related to the virtual file system. So for us, it's always, people have been talking about this for years. It's a question, when do we claim victory that POSIX extensions are done? And I think we can never really claim victory, because even NFS isn't fully POSIX. Try to unlink a file that is still open on NFS and you will see weird things that won't happen on local ext4 or something. What this little chat with my colleague this morning told me, we have a customer with very specific requirements. First, they need symlinks to work, and they need to be able to do a chmod from a Linux client in POSIX compatible way. And so these are much more concrete and much more approachable goals that we say, okay, we have individual aspects of the protocol that we need to make work. And there are specifications for all of this. So what do we need to do to make SMB a competitor to NFS? SMB is a file sharing protocol. You can open files, you can list them, you can delete them, and so on. But in detail, there are different semantics. For example, case sensitivity, some weird file names are not allowed on SMB that would be allowed on NFS or in POSIX, and so on. So we need to do something to extend the semantics of SMB. And thanks to the negotiate contexts that SMB2, or rather SMB3 have given us, we can now extend the protocol in a compatible manner. And what we did is we invented a new negotiate context, essentially asking the server in a very early stage, hey, are you able to do POSIX extensions? And if so, I would be, as a client, I would be asking for POSIX semantics on individual calls. This is what I call here the new negotiate context. Then we will have to define semantics for this file name handling that I spoke about. We need to be case sensitive. This is basically done. This is also already existing in the old SMB1 POSIX extensions that hopefully nobody uses anymore. And to implement this on a per call basis, we also invented a new create context. You can just have extended attributes essentially on a create call, extending it with arbitrary data, and we invented a POSIX create context using which you can tell the server, for this particular call, I want that POSIX semantics. Then, although you have a ton of different information levels giving you all sorts of ntfs information from any file on the system, we still have some things that are not really covered well, so we had to implement some new file information classes. For example, nlinks in the stat information isn't really well covered in the SMB standard information classes. We want direct control of permissions, ownership, and all of struct stat. I mean, we want to do as much as humanly possible inside normal standard SMB protocols, but there are some things we need to extend the SMB protocol with, like proper ownership or something. This talk is not about any of this, as you can see. If you are interested in the POSIX specifications, David has put together a very nice document where at least the format should look familiar to you. It's this here, and anybody who has looked at SMB specifications, it's just from the outside, it looks like it's an SMB extension, and this is exactly what it's meant to be. You can see this on codeberg.org. David, thank you. Great source of information. I mean, it's not long because we do as much as possible inside the normal SMB specs, but here you can see we have a new create context. We have a new create context. We have a new negotiate context. We have a new create context, and so on. We have new information classes. So anybody interested in this can take a look at this. Wireshark does know about these already. So it's all good that if you want to implement that, you will be able to analyze your traces properly. What will I be talking about here? About something that existed in SMB since, when did they invent reparse points? Tom? When were reparse points? I mean, even in SMB1, you have reparse points and the ability to query them, right?
Reparse points have been in the ntfs file system forever.
Yeah. Yeah, Tom just said reparse points have been there forever.
Object. They're a backing store object that's expressed via the protocol. Right.
Yeah, the comment was that they are a file system object essentially that is expressed over some. I mean, you do have some flags in the protocol. I will show them.
SMB definitely supports them.
Yeah.
Right, but they depend on the underlying.
But the point is, they have been there forever. We could have done this in 1990, whatever, in the 1990s. Or I mean, maybe early 2000s, we haven't yet, but now we are approaching to utilize reparse points properly to have extended file type support. I mean, one of the requests I got this morning was, I need symlinks. And Windows NT actually, or I don't know if NT does it, ntfs actually implements symlinks, and they are properly exported now over SMB with the proper error message and so on. But there's more. NTFS doesn't know about block, character, and fifos, and so on. I mean, you do have named pipes, but they are a very completely different object inside Windows. We have to represent them to make a proper home directory server for GNOME and so on. What we do, well, is regular files and directories. I mean, that's the whole point of a file server. You want regular files and directories. But how do we represent the other ones? I mean, where is Samba sitting? Samba is sitting on a Unix file system, one way or the other. And Samba does find special files like character, block devices, sockets, fifos, and so on the file system. How does Samba deal with them right now? I can only say badly. So for years we have had the ability that a server can create a FIFO on the that a daemon on a Samba share can create a FIFO, and that a client connects to it and writes and reads. We broke that. Nobody noticed. We broke that because Samba, when you talk to a FIFO, the Linux system will only accept pure read and write calls. It will not accept read v, give you an offset directly, atomically, and write v. It will give some weird error message. And we removed the normal read and write, which is the right thing to do, but it broke FIFOs. Nobody noticed. We don't have a bug report for them. And I mean, like 5 years ago, since 5 years ago, we don't do read and write anymore. Sockets, different thing. I mean, you could create a socket on a Unix file system and expect some level of semantics over the SMB protocol that you can connect, that you can read, that you can write. We don't do any of that. What we do right now is a daemon on Linux can create a socket, and over the IPC $share, you can connect with the named pipe calls that are there. So you can utilize them, but only in a very, very specific manner. And we use that for somebody's ERPC, our RPC system. Block and character devices, I mean, what do you want to do if you have dev SDA in your share, the character device, the block device? Do you really want to export that disk over SMB? I mean, I know there's essentially tunneling of iSCSI inside SMB, but this is not what I would expect a Unix server to do. So what we want is, we want to present all these special files in a way that a client can use them locally. Essentially the diskless boot. Enter reparse points. According to Wikipedia, reparse points provide a way to extend the NTFS file system. A reparse point contains a tag and data that is interpreted by a file system filter. What the heck does this mean? So what I found out by testing and playing around with them over SMB is my interpretation of things. I don't have access to Windows source, but essentially reparse points are completely normal files. You can read and write to them if opened properly. You can, they even respect share modes. I have tests for this. The only thing that happens is when you normally open a reparse point like you would open an application, very, very late in the open call, one of these filter drivers steps in and sees, hey, there is an extended attribute on the reparse point. There is a tag. And when it is there, then very late in the process of opening a file, we go through the list of filter drivers that we have. Does anybody know about these reparse points? And then call a callback and do something. And if it's not there, get a special error message. I have status IO reparse tag not handled. And that's the only thing I could find when reparse point, what reparse points actually do. So when opening a file, very late in the open process, if I don't open a reparse point as such as a reparse point, if I do a normal open, somebody can step in with a callback and modify that file on the fly. So MS-FSCC defines a few dozen of these tags that can be set as extended attributes essentially on NTFS files. Most of them are labeled as not meaningful over the wire. The specification says 2 types of reparse tags are documented. Actually, that's a little bug. The SMB2 document or FSCC document specifies 3 of them, and we will use them. Essentially, when you read not meaningful over the wire is, we don't think we need to document them, but I mean, the ones that we are going to utilize are documented. Ralf?
One question here. So you said there is something like the notion of opening the reparse point as a normal file or opening it as a reparse point.
Yes.
Or as some flag in the protocol, right?
Yes.
Can you detail that a little bit, because I somewhat fail to understand what the...
That's a normal create request open. The question was, I spoke about opening as in a file normally and as a reparse point. The only difference is this is a normal call to open FIFO, and the difference between normally or opening it normally and as a reparse point is this bit here. So at the in the moment of the create call, the client can tell the server, hey, I'm interested in the normal file, in normal semantics and whatever. Please reinterpret this reparse point for me. Do whatever you want with it. Like whatever open, there's definitions for HSM, which means that a hierarchical storage manager could step in when you open the file and just pull back stuff from tape before returning to you. That's, if this bit is 0, which it is here, then all this mechanics stepped in. So, but this FIFO is not handled here in that file server. So it is a file with a reparse tag, which we don't have a filter driver for. And what you see here is an error message. And what we do next is we create again, same request, all bits the same, except for this one. Open reparse point. And this tells the server, hey, don't walk the list of filter drivers to see if anybody has any business in this. Just give me the raw data without interpreting. And this succeeds. And the point that I wanted to make earlier is when you have this handle, you can just normally read, write, truncate, whatever you want with it. You have share modes. I mean, you get share modes for these open calls. Even if you say, okay, I have a reparse point, I don't want the filter drivers to step in, everything just happens as it would with normal files. It's a normal file with a special attribute.
There would be a symlink reparse point, it would just at that point like follow this.
We'll get to that.
Okay.
Any other questions? Good. So, where do we come from? We want to represent all these special files. And we see that we have a few dozen reparse tags defined in MSFSCC. And there's two special definitions of reparse points for all these two objects. Where do they come from? Microsoft implemented the Windows subsystem version 1. Version 2 works completely differently. But they had the same problem. They wanted to present Linux semantics based on Windows NTFS. And what they did is they invented reparse tags. Just files with extended attributes. They have a name, they have all attributes, like you would expect from a file, but they invented reparse tags. For example, we have reparse tag AF Unix is used for socket, and so on. The problem is none of these are documented, and they are definitely not used anymore at all, because WSL1 is essentially completely deprecated. I don't know if you can still install it if you want to. WSL version 2 essentially is a complete Linux kernel using ext4 on a block device, so they don't have to mess with any special semantics being added to NTFS files. And then there is the Windows NFS server. And that also has the same problem. The Windows NFS server needs to cope with a client coming in and saying, okay, I want a FIFO, I want a socket, I want a block device. And they invented a completely different set of reparse points. And the point is, these are actually documented. If you look at MSFSCC, excuse me, these are actually documented in MSFSCC, and what these guys did is they didn't talk to these guys and look at what they did, but they invented one more reparse tag, and they added a sub-definition of, or a sub-tag, am I a socket, am I a block device, or am I an NFS symlink inside the blob that is covered behind IO reparse tag NFS. If you look at the specification, the obvious thing happens. For block and character devices, you need major and minor numbers, and they are just, so you have a reparse tag, IO reparse tag NFS, with a sub-tag telling I'm a block device, and then you have 8 bytes, 4 bytes for major, 4 bytes for minor, for block devices, as the data content of this reparse tag attribute. Symlink has as target a Unicode symlink target, essentially. I mean, they could have used the normal POSIX symlinks, but they didn't. And FIFO and SOC as special reparse tags don't need additional data. They are just being given a special tag inside the IO reparse tag NFS data definition. You can look that up. And let's look at what Windows does with these. So here, wait a second. I know you can't read that, but I found this key. Now you should be able to read this. So these are files that I created over an NFS client, via an NFS client. This is a block device. This is a FIFO. You can see what I mean. The bar is a target of a symlink, or it's an NFS symlink, I don't know anymore. But they are represented here as completely normal files. And if you go to the command line, still normal files. I'm sure that at some point, in some place, I saw that. Wait a second. Possibly, if I come over SMB, I get special attribute, or if I look at this properties here, somewhere all these reparse points have been listed as symlinks. I don't remember. I've seen this. So here, live demo time always breaks. So this is a proper NTFS symlink. This is the one that is actually being used in the real world. I mean, who uses the Windows NFS server? It's just there. But this is actually being used. And this is what Explorer is aware of. So what Explorer sees when listing this directory, it sees, hey, this is a reparse tag. And all it does is, it tells you it's a symlink. Maybe they fixed that in some update. I've done run updates on this machine, but what I've seen is that Explorer also has all of the other ones here as symlink. So this is not really consistent to the end, even in the Windows world. So, but what you see here is a use of normal symlinks. Let me exit this here.
When you say normal symlinks, do you mean POSIX symlinks or SMB symlinks?
SMB symlinks, no, NTFS symlinks. NTFS symlinks. Oops. So now we have to make a choice. We want to represent all these special objects. What do we use? And my strong vote is that we use these here. Why? WSL has distinct reparse point tags. So we have the WSL1 definition and we have the NFS server definition, and I would strongly vote for the NFS reparse point definition. WSL no longer used, and probably they won't reuse these tags, these reparse tags, for something else, I'm sure, but still the format is completely undocumented. I mean, you will be able to figure that out, but it's completely undocumented. NFS only uses one reparse tag, and if you look at what is arguments pro NFS, we do have documentation, and what we can do is we can do protocol level tests against the definition of interoperability, which is the Windows NFS server on NTFS also being exported by SMB. So we can play with, hey, this is the standard for this kind of interoperability. Let's do the NFS make link, NFS whatever, NFS make socket, make FIFO, and see what happens on the SMB side. And we want to be compatible with that. WSL saves us a round trip on directory listing because it has distinct reparse tags per object. So when you do directory listing, in the query directory call, you only see, hey, this is a reparse tag for NFS. It could be a FIFO, it could be a symlink, it could be a socket. And to satisfy ls minus L, to print as a P or a S or a whatever, we need to look in the data contents of the NFS reparse tag. And that's another round trip, but I think we have to bite that bullet. Symlinks, big troublemakers. We had our share of security issues with that, but they are there. They are not going to go away. although Jeremy really wants them to go away, but they are going to stay, at least until I retire, I'm pretty sure. So, for symlinks we have even 3 options. There is the WSL specification, there is the NFS specification, and, as I mentioned quite a few times already here, ntfs has reparse tag symlink. And this is one of the moments where a standard Windows server can actually do something with a reparse tag. I told you that when opening a file very late in that process, all the filter drivers step in and say, okay, let's do something with this, and the reparse tag symlink is being properly dealt with in a standard NTFS, in a standard Windows SMB server. And what does it do? If you try to cross a symlink, when opening a file, you get a special error message. As we have seen already, when opening a symlink with a FIFO that nobody can interpret, you get IO reparse tag not handled. No filter. I mean, this is a reparse tag, but we don't have a filter driver for it. Every NTFS does have a filter driver apparently for IO reparse tag symlink, and does something with it. What does it do? It gives you a special error message. There you go. So this happens when you cd into a directory or whatever, I don't know. I think I did a all info or get on LNK, which is an NTFS symlink on a Windows server that you can create with mklink on the Windows server. And what it does, it returns, hey, stopped on symlink. And what it also does, is it gives you a very informative error message. Namely, let's open this. Crap. Namely, what it does is it tells you, hey, the symlink is at this point of the path you have given me. So imagine you're open a/b/c/d/x.txt, and somewhere in the middle, for example, b points somewhere else. Windows is always completely path-based, so you always give it the absolute path from the root of the share to open a file. And if somewhere in the middle there's a symlink, in SMB1 what you would have to do, you also get that error message over SMB1. But what in SMB1 you would have to do is just open the individual components piece by piece and ask the server, hey, is this a symlink or not, and where do you want me to go? SMB2 error message gives you this unpassed path length, so it tells you, hey, a/b/c/d, those bytes, those 10 bytes of the path you've given me, I have not looked at. This means that /b is the symlink, and where does it point? The symlink points here. And the interesting thing is that this can be anything. Depending on Windows client settings, this can even be / server name / share / path. So essentially what we have done for MSDFS, for example, is we have a special error code, path not covered, and so on, and then the Windows client comes back to us, and where do we need to go? You could do essentially all of this with symlinks. So what you can put here is the symlink target. And this makes it easy for the client to interpret all this stuff on the client side, which is good. Yeah. The question was, what happens if there are several reparse tags in the path? My guess would be, I haven't tested this, but my guess would be that Windows just goes from the top, it does the path traversal, and whenever it hits the first symlink, it just bails out and tells you, hey, I can't traverse this one, it's a symlink. Interpret that yourself and get back to me with the new complete path and so on. That's my idea.
That's what will happen. That's what will happen.
Yeah.
That's definitely what will happen when Windows encounters a reparse point, but I don't think it allows more than one reparse point on the file.
Yeah, that's true. I mean, you can it's just one external.
It's either a file or a reparse. It's almost like the type of the thing rather than an attribute that's added.
But I think the question was, you have /a/b/c, if both /b and /c are some kind of reparse tag.
Oh, well, you'll be tracing multiple as you just send the list.
Yeah, exactly. So my idea is that, Jeremy.
What is that e-loop detection strategy?
Client-based. The question was, what is e-loop detection strategy? It's like an NFS. NFS doesn't deal with symlinks. You have to do that in the client.
I just wondered if you knew what their limit of looping was.
The question was, do I know what the limit of e-loop detection is? No clue.
I know there's loop detection in the file system, but if you were to assemble a weird tree of shares.
Has to be in the client.
Well, yeah, the client is.
No. Tom said there is some loop detection, but it must also be on the server side because it must be in NTFS somewhere. Or somewhere, because you can also do symlinks purely server-side without SMB.
You don't need an SMB to do any of this. So
Yeah.
there's protection already in it, but you're right, especially if it vectors you to it. I'm going to have to think about that. But yes, the client needs to protect against loop.
Jeremy's comment was, I hate symlinks. Watch his talk from Samba XP.
Yeah, there has to be an option in the error path that says like how much path is actually covered, and if you go back to the previous response, there has to be some offset pointing like under which path is actually covered.
You're talking here, this one.
Yeah, that signifies until which point is actually a regular path, and that's where you have encountered another symlink in the path that has to be.
I didn't fully get the comment, but I think Windows just stops at the first encountering of a reparse point. It wouldn't even look further. And it just would treat, I guess, the rest of the path that you have given to Windows beyond that reparse point as gibberish and client deal with it.
Unparsed, yeah. It's.
Unparsed, exactly. That's what it says.
I stopped on this component and I ignored all the others.
So it's completely up to the client. And as I said, you can send the client to a different server with this, with proper settings on the client. It's some fsutil settings that you can say local to local, local to remote, remote to local, and so on, activated or not. But you can send Windows clients to other servers if properly configured on the client. So, what do we do in POSIX extensions if somebody coming in from the Windows client wants us to create a symlink? The big thing is, no, we won't create a server-level symlink. What we will do is, or how would we create symlinks over SMB? There's a standard way for it. Essentially just create a reparse point, and the client will use that facility, create a file with reparse tag, fsctl, set reparse point, and be done with it. And we will just follow what the client tells us. Create a file, set that special extended attribute, set the attribute, yes, I'm a reparse point, and be done with it. The option would have been that somewhere in these two steps, we actually turn this into a real server-side symlink, and we won't. This is what gave us security headaches all over the place, and moreover, you can't do this because these two steps I point out, just create a file with open reparse point, and I think you don't even need that. You create a file, and only later the client tells you this will become a reparse point. And there is, on Unix, there is no atomic way to turn a file into a reparse point. So when we have created that file as a normal text file or whatever, it's too late. So there is no atomic way to actually turn this into a reparse point, which benefits us, that we don't even start to mess with reparse points on the server side, with symlinks being created over SMB. Jeremy.
Does Windows have a restriction if you open a file, write data into it, can you then turn that file containing data into a reparse point, or does it have to be zero?
The question was, does Windows have a restriction that you can turn a non-zero or a file with real contents into a reparse point? No, it doesn't. You can have a 10 megabyte file, turn it into a symlink, essentially. There are restrictions for directories. You can only turn a server-side created directory into a symlink when it's empty. That's what it is. And if there is a reparse tag on a directory inode on the server side, you can't create files in there anymore. But for this, I would strongly vote for we don't do that on directories. We just don't. Because it causes us all sorts of other trouble with our internal optimizations and so on. This just won't work. So in Windows, you can create a directory, turn it into a symlink. We will not support this. Ralph?
So if we only support it on files, but can the symlink target then be a directory?
The question was, can the symlink target that we create as a reparse point on the server side be a directory? It can be anything. It's a blob. It's a blob that the client has to deal with. We just return the blob, period. And the blob is essentially this whole thing here, reparse data length. So this is the error message. And you have, essentially, it's this object, these blue bytes there, that we have to store in, that we have to get into the fs control set reparse tag with all the data in there. Unpassed path lengths, it's a reserved field. You have flags, flags one meaning it's a relative or absolute symlink, and then you have these two fields, first the substitute and the pretty printed name and so on. When creating a symlink over SMB, you have to give it this whole thing. For the server-side filter driver to turn this into an error message stopped on symlink. But beyond that, it's completely a blob. I mean, I haven't really checked if we tell it reparse tag symlink and then just give it like a 10 megabyte random set, whatever, whether there are any consistency checks. Sorry, Steve was first.
Yeah, so I was looking at, let's Google that, because I was kind of curious, and I haven't tried it, but it said that 16K maximum for the reparse data. So maybe you're safe?
The comment was that there is a maximum size for reparse data. Might be true, but in general, I have already tested that you can, in general, just send garbage as part of this. There might be size limitations.
Yeah, I agree you said the garbage, but what I'm getting at is it's less likely that you're going to put an enormous virus in something, if this is true, the application that says that it's a capped size. How much data you put in there?
Don't know.
Yeah.
Jeremy.
I actually talked to Dave Grohl about this, who just did the file server, and he confirmed that in NTFS it's stored as an extended attribute, so all the limits on size of extended attributes are applied to the symlink reparse data.
Yeah. The comment was that essentially it's implemented as a normal extended attribute with some special whatever magics icing on top, but it's an extended attribute with all the restrictions that apply to extended attributes. Oops. Okay. So where are we now? We have server code, I mean not in master. We have server code where you can set and get reparse tags on normal files. We also do have server code that gives you, for real symlinks, and we tested this in the I/O lab already, for real symlinks, also we export a share, there is a Unix level symlink, and Samba can now get the proper stopped on symlinks, including the metadata, redirecting the client. And this is activated right now. We have this option, follow symlinks equals yes or no. So you can make Samba follow symlinks server side. Some would say bad idea from the start, but it's there. And people depend on this. Right now, the code I have presented to Steve is that this stopped on symlink happens if you say stopped on symlink follow symlinks equals no, and if you then come in with POSIX open request, so you get a create request with the POSIX create context, it will always activate follow symlink equals no. So we will not have in the POSIX world, in the POSIX extension world, we will not have server-side followed symlinks at all. I mean, then next question. Currently, fifos are broken. Shall we use those as a test bed for this logic with getting fifos? Same for sockets and block and character devices. We could just say, if a client comes in and does a create on a non-normal file, we give it reparse tag not handled, and then the client needs to figure out, hey, get me what it is. We could do that pretty simply. The question is, does that break user scenarios? Can we just activate this? Do we want to activate this? I mean, I have code for most of this already. Do we want to activate this by default? Just do it. Jeremy.
Well, if nobody noticed that fifos were broken, I would say yes.
Jeremy's comment is that we don't have bug reports for fifos being broken. Just do it. Steve? Oh, Paulo.
Instead of returning IO reparse tag not handled, you could just use the create response reparse point flag to define that the file is a file.
The comment was that in the return of the SMB create, we have a flags field, and we could activate, hey, this is a reparse point. But I mean, what do you do with that handle then? I would vote for, yeah, I would vote for reparse tag not handled and just not deal with it. And yeah, Steve.
In any case, we have code today to query, to read this, right, for read fifos. So if you expose one, that code should work okay with. I mean, we may have bugs. We'll look at that. That's what we can do this week. The thing I was curious about is, should we allow? I mean, I don't have code to create fifos this way. I mean, obviously the older ways we do, but we don't want to be using the 20-year-old way with extended attributes to do this. We'd rather be doing it this way. If you want tomorrow or today, we can do the create FIFO with the reparse tag and see if you add it to the client code. But right now we should be pretty close for reading the FIFOs.
Yeah. The comment was that the CIFS client right now has code for creating a FIFO using the reparse tag method.
No, we do not.
You do not.
We have code to query
okay.
and recognize it. So we tested that to Windows at a previous Plugfest. But creating the FIFOs and creating block and creating care devices, we only do the old style way.
Mm-hmm.
The whatever that is, the INTF, the interlink, whatever it was. And I think we should use FIFOs as a guinea pig because it's a safe guinea pig. But I have to add the code to create. Right now, if you create it on the server, I can read it, hopefully. But creating it, we can do that today or tomorrow.
Yeah. So the comment essentially was for the recording that there right now is no code to create FIFOs and special files using the symlink method that is laid out here. And so, but that should be relatively simple to add, I guess. Yeah. What is incomplete is doing all of that over SMB1, but the question is, I mean, we do that using Unix extensions already, and so it's not complete, but we need to do. The question is, do we need to do that? Probably no. And right now I'm working on libassembly client to include user space clients, and there's one little demo that I could try to give you here, and that's this call essentially. What do I have? It is a normal SMB server localhost, And what we have in Samba is our usage of, is examples of our exported libassembly client that use this weird SMB URL and that can then issue a stat call. And I have extended this such that, and let me open a Wireshark trace, TCP dump, temp stat cap. So this is an example client of this exported libassembly client, and the point that I want to make here is this, that this code is now able to fill in this stat field with the contents of the reparse tag. And if you look at, this is the exported share, I think it's git share FIFO. This is the object server side. Oops. This is the object server side. It is a FIFO, and we correctly now report this as a FIFO. And if we now look at the Wireshark trace currently being taken in temp, so this is live. Let's limit to SMB2. What it does, it tries to, and now you should be able to read this. I mean, this is the sequence that you have already seen, but it's live. I'm done almost. FIFO, we get a reparse tag not handled. Then we open, and just trust me with reparse, open as reparse point. And then we do the get info, everything, and then we do the get reparse point on the FIFO, asking, hey, what do you have? And this piece here then is artificially generated as a reparse tag ntfs, and it's a FIFO. And yeah, so this works server side. Client support is still a bit lacking, in particular with symlinks and so on. I mean, that's a nightmare in our client, in the user space client, SMB client, libassembly client, and so on. That's a nightmare to get right in all cases. Okay. And with that, thanks for your attention. It was a good discussion. Thank you. Any questions beyond what has been asked during the talk? We have 3 minutes left. Yeah.
If a client tries to create a symlink over SMB that actually points, that's a global symlink that points to a different SMB server, will you accept that just like store by default?
The question was, will we accept weird symlinks pointing outside server and so on? Yes, we will, because essentially what I said, what we get is this blob. And essentially we don't really care about this blob. It's a blob that we store as an extended attribute. We can always say, okay, do some sanity checks and look at the contents of this block, where it points and whatever, forbid pointing out of the share or something, or only support relative and non-absolute symlinks and so on. We can apply all sorts of consistency checks, but server side we don't care. It's for the server, it's not a security issue. Because it's just a blob that we store in an extended attribute.
Right, but then you said that this is only working when follow on symlink is disabled.
Correct.
What happens if you encounter an actual POSIX symlink?
When we the question was, what happens if we encounter a POSIX symlink? We artificially generate this, and the only thing we take from the file system is this substitute name, and we will have to apply some magic, and I have code for that. We look at right now we look at the code at the symlink target and make a check, does this point into the share? If it's a relative symlink, we just report this. If it's an absolute server-side symlink, the current code says, does it point inside the share? Then we cut off the share root, make that a relative symlink. But that's all magic that can be discussed. So if we have an absolute share pointing back in the same directory server side, we turn it into a relative symlink that then the client will interpret properly, hopefully. And if none of these heuristics make sense, we just pass it back as is. Steve.
So obvious question. So obviously I prefer fewer round trips when we're creating things. Today with special files we can use SFU, which if you support X adders or not, we know it will work or not. If you support MF symlinks, all will work, right? So
We do support MF symlinks today.
That works fine. So that works fine. But if we're going to do this for, let's say, fifos and whatever else, one of the problems I see is how do we know, like a normal server, let's say Windows, you can either create a reparse point or you can't. If the file system supports creating reparse points, all reparse point creates will work. If not, they'll all fail. Here, what we're looking at, I think, is that we may get errors creating a FIFO with, I don't know, the NFS file, but it won't work with.
No. The question was, when NTFS supports creating reparse points, or reparse points will be created, will be the same here. Okay. Because for us, we will implement this, or I have code, and based on Jeremy's code, that implements reparse point just as an extended attribute. Okay, so and we don't care, and this is exactly his question, we don't care what the contents of the exatter is. We could apply all sorts of magic and sanity checks and so on, some kind of filter, but the server doesn't care.
The advantage of this is you can expose them however you want. I'll read those, I'll see them. I can create them however I want, and you don't have to worry about them.
Correct. And I think with that, we are 1 minute over. Hey, out of time. Perfect. Thank you.